Hello, this lecture is based on the textbook Combinatorics and Graph Theory. We are starting section 1.3 on trees. So we'll look at the definition and examples. Here, the graph A, B, and E are examples of a tree. A tree is a connected graph that contains no cycles. So C is not a tree because it has a cycle, and D is not a tree because it has two connected components. A forest is a collection of one or more trees, so all of these graphs here are forests except for C. And if I'm not mistaken, the Chinese character for a tree is a tree itself, but this character also means a forest, which is a picture of a forest. And we say that a vertex which has degree 1 in a tree is a leaf. So now let's look at the number of trees. So there's only one tree if n is equal to 1, 2, or 3, and here are both of the possible trees on 4 vertices, for 5 and for 6. Let's look at some applications of trees. Trees are useful for modeling the possible outcomes of an experiment. For example, here we have an experiment in which a coin is flipped and a 6-sided die is rolled. And we can make the following tree where the leaves of the tree correspond to all of the possible outcomes in the probability space for this experiment. For example, here, this leaf corresponds to when you flip head on the coin and 2 on the die. Another application is you can use tree to model the logic of an algorithm. So for example, here we can consider making a program that finds the maximum of 4 numbers, so W, X, Y, and Z, and we can represent this logic by this tree, which is called a binary decision tree. So for example, if we have a number like 5, 5, 2, minus 1, first you would compare the first and second entry, and it is true that 5 and 5, or 5 is bigger or equal to 5, so you move on to the next row of this decision tree, and now you compare the first and third entry, and here 5 is bigger than 2, so you say yes, and then you compare the first entry and the last entry, and in this case W is bigger, so we end up at this leaf, and we see that all of the leaves correspond to all of the possible outcomes for any tuple of 4 numbers W, X, Y, and Z.